So here's the circuit board we're going to be building. We're going to be adding components onto the back side, so not the copper side. We're going to put that aside for now. We need to use this little pin dip rather than our chip, so we're going to set the chip aside. The audio jack, the electrolytic capacitor, 1000 microfarads, 10 volt rating, the little ceramic capacitor, 0.1 microfarads, the resistor, 10 ohms. Set all those aside for now. And you have a nut and washer for the 10K potentiometer, your speaker, 2 wires for that, and then more washers and a nut for your switch. You can set this aside. We just need the switch and the 9-volt battery clip to start with. And we're going to just take that 9-volt battery clip and snip the red wire about in half, and then strip the ends off of those wires about a 1/4 inch. And then you'll need to twist the ends so that you can then thread them through the holes on the switch. And it doesn't matter what side, this is just your on-off switch, so we're just putting a break in the circuit. So once you thread your wires through, you're going to twist them. And then solder your switch onto the 9-volt battery clip. And you can set that aside. You're then going to take your 3 wires, about 4 inches long, and strip all the ends and twist all the ends. And then you're going to wrap them one at a time, one end to the prongs on your potentiometer. And it's easier if you solder them one at a time rather than all. So I've got the black wire here, and then you want to tin the tip of your soldering iron first by adding a little bit of solder. You want it to be shiny, so you need to do this a few times if the tip of the iron doesn't have solder on it. And then you'll be ready to heat up the wire joint, and then you can twist your next wire on, and the helping hands can hold your component in place. And every time you solder, you're going to need to clean the tip of your iron off. And if you melt a little bit of plastic, that's okay. And then if you don't have enough plastic stripped off your wire, you might need to strip a little bit more in order to wrap it around. So you want a secure connection before you solder as much as possible. And once you've soldered those 3 wires on, the last thing you'll want to do is tin the tips of those wires before you set it aside. And you'll need a black and red wire for your speaker. Strip both ends, twist them, and tin both ends of those wires. One end's going to go into your board and the other will go into the little white jack to hold your speaker, or to connect a different speaker if you choose. You want to make sure that the solder isn't making a blob at the end, because you will need to stick it through the little holes on your board. You can use the cutters to snip the ends. Alright, now we're ready to attach our components to the circuit board. You want to make sure that you are putting the components on the non-conductive side, and we're going to use a 8-pin dip that our chip is going to fit into. Note the little chip at the top of our chip, the little indent. We want those to line up. And the reason we're using this is because we don't want to fry our chip with too much heat from the soldering iron. I'm going to look at pin 4 because I know pin 4 is where I'm connected to ground, and I can see here when I designed the board that this is my ground trace. So I'm going to line pin 4 up with ground, and that's how I know where everything should be connected. So I'm just going to stick it in there and then lay it as flat as possible. It helps to put something underneath one side if it's a little lopsided. You can use a switch to do this, just to keep it from tipping. And then I'm going to carefully put my soldering iron tip right in the area that the wire from the pin dip is coming through, and guide the solder onto the trace. Now, not all of the you can see not all of the pin dip legs, they don't connect to everything. So like pin 1 and 2, those don't connect to anything. Still solder them in place to hold your pin dip onto the board. But the 5 areas that are connected on our circuit board, those are the most important ones. So right there, you can see the solder will flow into the traces. That's fine. That's actually going to ensure a good connection. You don't want so much solder though that any of these are going to bridge. So just make sure that you aren't having any shorts between these areas. And that is done. And again, this is where the chip will be attached. Do not put the chip in until you are done. So the next thing we're going to do is the audio jack, and that goes down in this corner. So this board has an overhang. The component is actually larger than the board, but we're not connecting to those pins on the audio jack, so it's fine. We're just going to connect to ground, which is right here in the center, and one of the sleeves of our audio jack. So again, I'm going to solder these 2 spots, but then I'm also going to just solder the other 2 as well. And if your solder gets stuck to your board, as you can see here, all you need to do is apply a little bit of heat and it will release. And so these aren't connected to anything, but because the copper pad is there, it can hold the audio jack in place. So now that's secure. I'm going to add my resistor next, and that's going to go near the audio jack. To add this, you'll put one leg in and then thread the other through and pull it as close as you can to the board. And then to keep it from falling out, you want to angle the legs outwards. And to keep the legs from shorting anything, try to guide them in line with the trace that they're connected to. So you can see I pulled it along the trace. So if any solder flows from the wire onto it, it's going to go onto the trace and not anywhere else on my board. The other important thing I need to do is I need to snip these long legs before I go on any further, because I don't want them to get in the way and I don't want them to accidentally short anything. So now the resistor is in place. I'll take my 0.1 microfarad ceramic capacitor, do the same thing with that, bend the legs out so that they are kind of following the path of that trace, and I'm just going to apply the solder to fill those little holes and attach the wire to those traces. And you can see how close these traces are. Even if you do apply a little bit too much solder, you can see I'm actually trying to short this and make a bridge between those two. The solder is very difficult to get it to do that, so if you happen to bridge it, if you clean the tip of your iron off and then you wipe it between, it will pick up the solder that is in place. So once you've gotten your components in place and ensure that nothing is shorting, that there is a gap between your components in the center, just snip the ends of the wires, and I'm going to do the electrolytic capacitor. And remember, this one has polarity, so make sure that you are paying attention to the short leg that has the negative marking on it, because on our board we need to put that in the right spot or else it won't work. So on the board you can see there's like a little square around some of these pads. The square indicates that that's the negative. So on my board, I kind of ran out of space when I was milling it, so I have a little bit of a overhang here with my positive leg. I'm just going to bend it over and connect it. Your boards will have a full hole milled out, but as long as those are connected, it's going to be fine. So now I've got all my components in place. All I have to do now is add wires. And again, the negative is this little square pads made for our speaker. Solder them through the back, and you might need to twist your wire a little bit more or snip it. You don't want the ends of your wire to be super long for this. They just, 1/8 of an inch is fine, but you can see how I twisted it in to get it to sit flush with the board. You don't want exposed wires, or the interior of the wire exposed, so try to push it into the point where the plastic of the outer coating is flush with the board. So you can see here I still see the metal of the wire. I want to keep twisting it until it is actually in there. And if you're having trouble, again, just try to twist it, or you can take it out, twist it by hand, or snip the ends a little shorter and add an angle so that you can push it through. So this is what you want. And then you have 2 small pieces of wire coming through, enough that will reach through the whole board and touch the copper part. And then that is where you will solder to keep them in place. So now the audio cables are in, and these 2 ends are going to pop into the socket. Remember, if you didn't tin the tip of your wires, this will be more difficult. You can use solid wire as well, but it may snap, so just be mindful of that. Next, I'm going to do the power, and that's going to go into this side here, again, that one branching trace that has a lot of the ground traces attached to it, that's where we want to put our negative. So it's important not to get these backwards. So if you can remember that pin 4 is ground and has the branching, that will be helpful. And then your positive. And if there's any wires sticking through, you want to snip those. And you just want to make sure that there is a gap between the two. This is the one you definitely don't want to short between our power supply. Your battery will just get really hot. And the last thing we're going to do is the potentiometer with the 3 wires. Again, you may need to snip your wires down if they are a little long. You may also need to twist them or cut the wire at an angle to get it into your board easily. So I already tinned the tips of these, and I'm just trimming them down, making sure that they're all fully through the board, and using the helping hands to keep the board in place. And the last part I'm going to do is this, the one attached to ground, the one attached to the volume. This is going to be our volume knob, so that's our wiper, the center of the potentiometer, and then the last one. And that is all the soldering. Before I go any further, I do want to make sure that these are good connections and that I didn't miss anything. And to do that, I'm going to grab my multimeter and I'm going to set it to the continuity testing. The continuity testing, where it will beep. So when these 2 probes are connected by something conductive, they will beep. So if I put my one probe on this trace and then the other end that the other component is soldered to, I believe this is my power, it should beep. And any component that shares this ground trace should beep if it's connected. So you can probe around your board to make sure that everything is connected in these areas. And you can also use it to make sure that areas like right here between power and ground or the capacitor are not going to beep, because if there's a beep there, that tells you there's a short. The last thing I'm going to do is I'm going to make sure that my LM386 amplifier chip is placed correctly into the pin dip, and you might want to check the legs to make sure that they're not bent and that it fits flush into there, and then everything is ready to go. All you need to add is an audio cable before you test it and your 9-volt battery. So that will be the next thing to do before moving on. You don't want to put this into the amplifier tin until you've tested it. So insert the audio jack, make sure that it is inserted fully, that it clicks, and that it's a good connection there. And then the audio jack other end is going to be attached to your phone or your laptop, whatever can play sound. Clip a 9-volt battery in and test it out. So you're going to take your tin and make sure that you put a piece of paper or a thin piece of fabric. Anything thicker might dampen the sound, so paper is probably the best choice to keep your board from shorting, because this tin is aluminum, so we want to make sure that nothing's going to get hot inside here. So it's really important And then you want to grab the washers and nuts as well. And we're going to line up the audio jack. That's the one part that needs to fit into the holes. And again, these holes you would have needed to pre-drill. They are going to need to have the 2 holes in the one corner that's going to line up with your audio jack and your power, your on-off switch. So I put the audio jack in line there, hold it in place, keep my speaker out of the way, and then pop my on-off switch through the second hole. Again, try to hold that in place while I feed the potentiometer through the third hole in the front. And then this is where you're going to need to line up the first washer. Has this little indent on the switch itself that's going to line up with. So for it to fall down, it needs to go on that thread so that it's flush against the side of the Altoid tin. And it is a little tricky. You do need to kind of feel for that, or see if you can find it, and then once you do, it'll lay flat. And then put the toothed washer on next, and then the nut that fits on your switch, and then you'll just twist that down. And for it to really be snug, you're going to need to use needle nose pliers or the tips of the wire strippers to tighten those nuts in place. Otherwise it's going to be loose. So you want it to be as tight to the surface of the tin as possible. And then there are audio jacks that you can buy that have a threaded part on them, but these are what we have. I have these 3D printed parts that can go over, and we can add some super glue to keep it in place. I do recommend popping your audio jack in place while the tin is open. And then the last part is adding a washer and nut to your potentiometer, again using the plier tips of the wire strippers to get that tighter. And then the very last finishing touch is going to be popping the plastic cap onto the potentiometer, so that's our volume knob. And the speaker, you can kind of seat it right in the center. You can opt to poke holes or drill holes into the top of your tin if you'd like. Just don't forget the paper for the insulation, and then everything should fit snugly inside. And you can make sure that the audio is working. And that's it.